Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating critique and proposed overhaul of the C-Time API. It's a surprisingly complex topic, but stick with us. It's going to be exciting.
I'm eager to hear this. The C-Time API. I've always found it a bit clunky. What are the core issues this article highlights?
Absolutely. The author points out a plethora of legacy issues. Think obsolete design choices dating back decades. For example, the time function unnecessarily takes a pointer argument. Even though it doesn't need to modify anything, it's just inefficient.
Right, unnecessary overhead. And what about strafe time? That sounds familiar.
Oh, strafe time is a real headache. It forces you to use a fixed-length buffer, preventing dynamic allocation. In today's world, that's a major limitation. Plus, local time needs a pointer to a time_t value, even if it doesn't modify it. A relic from PDP-11 register size constraints?
Wow, that's ancient history impacting modern code. So the author proposes a complete rewrite, right?
Not exactly a complete rewrite, but a significant rethinking. The core idea is to replace the current time-at integer representation with a date-long double, offering nanosecond precision. This eliminates the need for separate structures like timespec for fractional time.
Nanosecond precision sounds amazing. But wouldn't that introduce floating point precision issues?
That's a valid concern. The author addresses this by showing that the loss of precision with a long double only becomes significant around the year 2262. Given that most systems will likely be replaced long before then, it's a reasonable trade-off for the increased precision and simplification.
I see. Interesting. So what about the struct TM? That's another notorious part of the API, isn't it?
Absolutely. The struct TM is a mess. It's statically allocated, lacks sub-second precision, and has inconsistent indexing. The author proposes a cleaner, more intuitive struct allocatical to replace it.
And what about time zone handling? That's always a tricky area.
The author rightly points out the convoluted relationship between TZ set, local time, and the environment variables. The proposed solution involves creating a set of functions that handle time zone offsets and names more cleanly and efficiently, avoiding the pitfalls of the current approach.
So the overall goal is to create a more modern, efficient, and easier-to-use time API in C, addressing decades of accumulated cruft?
Precisely. The author even provides a GitHub link to a work-in-progress implementation of this new time library. It's a compelling case for a much-needed modernization of a fundamental part of the C standard library.
This is really insightful. Thanks for breaking this down for us. It's clear that the C-Time API is ripe for improvement, and this article offers a compelling vision for the future.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Join us tomorrow for another deep dive into the world of technology. Goodbye.
Bye-bye.